The Metropolitan Wastewater Treatment Plant is one of 9 water resource recovery facilities operated by the Metropolitan Council. Our Environmental Services Division partners, plans, and provides services to protect the water in the 7-county Twin Cities region. One of our services is treating the region's wastewater for nearly 2.7 million people in 111 communities and returning the clean water back to the environment. Cleaning wastewater is essential to protecting public health and the environment. This service is critical to the quality of life in our growing, thriving Twin Cities area. Today, the Mississippi River is beautiful and full of life. That wasn't the case when the populations of Minneapolis and St. Paul grew in the late 1800s, and raw sewage was channeled directly into the river. The river looked and smelled bad, cues that the pristine waterway had become a conduit for diseases such as cholera, dysentery, and typhoid. It was uninhabitable for wildlife. A 1926 survey of the river from the Twin Cities to Hastings found a total of only 3 live fish. The Board of Health declared the Mississippi River a public health nuisance. As a result, the Metropolitan Wastewater Treatment Plant was built on the river's shore. This low elevation point allows gravity to deliver wastewater to the facility and positions the plant to return large volumes of clean water back to the environment. It was the first wastewater plant on the entire Mississippi River. Wastewater flows from sinks, bathrooms, and drains in local homes and businesses into city sanitary sewer pipes that then connect to the Met Council's interceptor sewer system. The Met Council's regional wastewater system collects and treats nearly 260 million gallons of wastewater a day, a volume that could fill US Bank Stadium every 2 days. Wastewater is transported through more than 600 miles of sewer pipe, ranging in size from 7 inches to 14 feet in diameter. More than 60 lift stations pump wastewater higher so gravity can resume its work in moving the flow to one of our 9 treatment plants. More than 70% of the wastewater from the Twin Cities region is processed by the Metropolitan Wastewater Treatment Plant in St. Paul. Located on the east bank of the Mississippi River, just south of downtown St. Paul, the Metro plant treats an average of 180 million gallons of wastewater a day and has the capacity to treat 251 million gallons a day, making this one of the largest wastewater facilities in the nation. Staff operate the plant 24 hours a day, 7 days a week. It would cost an estimated $2 billion to replace the plant today. The wastewater treatment process manages 2 main waste streams, liquids and solids. Preliminary treatment begins as soon as wastewater enters the Metro plant. The raw sewage passes through bar screens that remove large items like sticks, rocks, and trash, items that should be kept out of the drain. Often, instead of reaching the plant, this debris clogs your home or business's sewer service line or blocks city or regional wastewater systems, causing expensive and messy repairs. The screened material is removed and conveyed to a large dumpster, which is hauled to a landfill when it is full. After passing through the bar screens, wastewater travels into tanks called grit chambers. Here, wastewater flow is slowed to 1 to 2 feet per second. This allows the heavy material, like sand, eggshells, plastics, and metals, to settle to the bottom. Scrapers pull the settled material, called grit, to one end of the chamber to be collected. This material is pumped out and loaded onto trucks that take it to a landfill. Next, the wastewater travels into the primary settling tanks for primary treatment. The velocity of the flow decreases again, allowing the floatable material called scum, like fats, oils, and grease, to be skimmed off the top and pumped to a dumpster that will go to a landfill. The heavier organic solids, called primary sludge, will sink to the bottom. Then the sludge is scraped to a collection sump and pumped to a process called gravity thickening to be further thickened. At this point, around 70% of the total solids that were in the wastewater coming into the plant have been removed. From here, wastewater moves on to secondary treatment, where microorganisms are introduced to the wastewater. The brown color of the water comes from the microorganisms in the water, often called bugs. Large aeration compressors supply fresh air to provide oxygen to the bugs through diffusers. These are similar to the bubblers in a fish tank. Under these conditions, the microorganisms grow, reproduce, and remove the remaining pollutants like carbon, nitrogen, and phosphorus. When the process is complete, the wastewater enters a final settling tank. Without added oxygen, the bugs settle to the bottom. After they are pumped off the bottom of the tank, most of the bugs are recycled back through the aerated tanks, while the rest are sent to be incinerated. The clean water flows over weirs and on to the final step in the treatment process. At this point, more than 95% of the original pollutants have been removed. The last step is the disinfection process. Metroplant disinfection is accomplished by the addition of liquid chlorine. This kills disease-causing pathogens, making the water safe for human recreation. Once the water has been disinfected, the remaining chlorine is neutralized. After approximately 15 hours of processing at the Metro plant, clean water is discharged back into the Mississippi River. While the liquids are being treated, solids are being managed in another set of processes. The solids from the bottom of the primary settling tanks are sent to gravity thickening tanks, where we let gravity thicken them further. The bacteria in the secondary process from the bottom of the final settling tanks are sent to flotation thickening tanks, where air bubbles are used to float the solids to the top. Skimmers rake the thickened solids into troughs. These two types of solids are blended together and sent to centrifuges to remove even more water from the process. Polymer is added to aid in the dewatering process, and the solids are spun like in a supercharged washing machine. The potting soil-like material that results is called cake. The cake is pumped into an incinerator like this one, burning at about 1400 degrees Fahrenheit. Once the incinerator is running, the incoming solids act as fuel to keep the incinerator going 24/7. Solids instantly combust into ash, and the state-of-the-art air emission control system removes most of the remaining pollutants, meeting or exceeding standard compliance regulations. The ash is then collected and transported to a landfill. As part of the incineration process, we take the hot gas and run it through a waste heat boiler. In the waste heat boiler, we create steam. We take this steam and use it to heat the entire plant in the winter. In the summer, it's used to run a steam turbine generator to supplement the plant's electrical needs. The water we return to the river must meet strict state and federal regulations. These regulations ensure that harmful amounts of pollutants are not being reintroduced into the environment. MCES takes these regulations seriously. The water that we put back into the river is much cleaner than the existing river water. The Met Council partners with both environmental agencies as well as entities like the University of Minnesota to monitor pollutant levels in the region's water. Wastewater facilities must have their treated wastewater tested daily to meet strict pollution control requirements. Water samples are taken from the final treatment stage at all 9 regional treatment plants and tested daily at the Metroplant laboratory. The lab processes more than 100,000 samples a year. Because of our dedicated staff, Metropolitan Council Environmental Services is consistently recognized for our success in protecting public health and the environment. We are committed to recovering water resources so that we can all have clean water for future generations.